Okay, continuing with our 1.2 basic derivatives notes, we are going to talk about the derivative of e and a couple other things. So a unique positive real number e exists that has the property that the derivative of e to the x is e to the x. The number e is irrational with approximate value e equals about 2.718. So we are going to find the tangent line to the graph of f of x equals 3e to the x minus 5x squared at x equals 2. So let's start by finding f of 2. We get 3e to the second minus 5 times 2 squared. And I'm actually going to type that in my calculator. And I am going to get about 2.167. Okay, so there's my ordered pair. Now f prime of x is 3, and then the derivative of e to the x is e to the x. And remember the power rule, 2 times 5, or negative 5 is negative 10, and then subtract 1 from my exponent. So f prime of 2 is 3e to the second minus 10 times 2, which is also about 2.167. So our equation of our tangent line is y minus 2.167 equals 2.167 times x minus 2. Okay, so here's our tangent line. Okay, another theorem, differentiability implies continuity. If f is differentiable at x equals c, then f is continuous at x equals c. So we're going to show that f of x equals the absolute value of x is continuous but not differentiable. Notice it said if it's differentiable, then it is continuous. It does not go the other way around in that theorem. So if we look at this, then we can see that f of 0 is equal to the limit as x approaches 0, the absolute value of x is 0. Okay, the limit is actually the same. We know that because if I look at the graph of the absolute value, it looks like this. Okay, so as I approach 0 from both sides, my limit is 0. However, if we go ahead and find f prime at 0, we're going to do the absolute value of 0 plus h. Actually, we're going to use the other definition because we haven't done that yet. We're going to do f prime of 0 equals the limit as h approaches 0 of f of h minus f of 0 over h, which is going to be the same as saying the limit as h approaches 0 of the absolute value of h minus the absolute value of 0 over h. Okay, and then you're actually going to see this one quite a bit. When you look at this on the graph, switch over to decimals here. Okay, you'll notice that there's actually a jump discontinuity there. So as we go from the left side, it's going to be -1. And as we go from the right side, it'll be +1. So we're going to go ahead and flip back here. Because the left and right sided limits of this are different, so h approaches 0 from the right versus h approaches 0 from the left, this is on the left -1, on the right +1. Since these are not the same, the limit does not exist. Therefore, the derivative does not exist. And then the last one, show that f of x equals x to the 1/3 is not differentiable at 0. We're going to do the limit as h approaches 0 of f of h minus f of 0 over h. So we have h to the 1/3 minus 0. That's a 3 over h. And if I simplify this, remember 1 minus 1/3 would simplify that to get 2/3 in the denominator. And I cannot evaluate that at 0. So this is infinity. I shouldn't say that I can evaluate it. When I divide something by 0, I can do it as many times as I want. So the limit is infinity, which means it's not differentiable. Here's your summary. I'm going to take some problems out. We're going to take out number 46 and number 88. There's quite a few there. You'll get the hang of it pretty quickly. If you have any questions, let me know.